Hello dear students of plus 2 medical, non-medical respected teachers. Today I am going to discuss Faraday's laws of electromagnetic induction. So let us start. To understand Faraday's laws of electromagnetic induction, first of all, let us discuss what is magnetic flux. Why? So magnetic flux means total number of magnetic lines of force threading a given area, and it is given by the dot product of magnetic field and area vector, or phi is equal to B dot A or BA cos theta. So this is the area and A vector is the area vector normal to area, B is the magnetic field. So theta is the angle between B vector and A vector. Then phi is equal to BA cos theta. So this is magnetic flux. When theta is equal to 0 degree, cos 0 is 1, so phi is equal to BA. When theta is equal to 180 degree, cos 180 is minus 1, phi is equal to minus BA. When theta is equal to 90 degree, phi is equal to 0 because cos 90 is 0. So it means magnetic flux may be positive, may be negative, may be 0. So magnetic flux may be positive or even negative. Units of magnetic flux. In SI system, the unit of magnetic flux is Weber. In CJ system, unit of magnetic flux is Maxwell, and 1 Weber is equal to 10 raised to power 8 Maxwell. Now, what is magnetic flux density? So, magnetic flux per unit area is called magnetic flux density, noted by B vector sometimes. Then, what is E.M.Induction? Now, to define electromagnetic induction, we'll discuss Faraday's experiment. Now suppose, what is Faraday's experiment? It consists of a coil AB connected to a galvanometer, sensitive galvanometer, and when a bar magnet, say with north pole downward, is introduced into the coil, that is moved towards the coil, then you will see this galvanometer gives deflection, say towards left, and current is anti-clockwise through the coil. And when magnet is taken away, again galvanometer gives deflection, but direction of deflection is reversed, say towards right, shown by dotted arrow, and direction of current through the coil will be clockwise. Because when direction of deflection of the galvanometer is reversed, direction of current in the circuit is also reversed. It means galvanometer gives deflection when we move bar magnet downward or away from the coil, or we introduced into the coil or take away from the coil. When both magnet and coil are at rest, then there is no deflection. Galvanometer can give deflection only when its ends are at some potential difference. It means whenever there is relative motion between the magnet and the coil, induced EMF is produced. And this phenomenon of production of induced EMF due to the relative motion between the magnet and the coil is called electromagnetic induction. It is immaterial whether the coil is moved or magnet is moved. There should be relative motion. But when both are at rest, there is no deflection. It means induced EMF is produced only when there is relative motion between the magnet and the coil. Now, moreover, when this magnet is moved rapidly, more deflection is produced. When magnet is moved slowly, less deflection is produced. So this phenomenon of production of induced EMF due to relative motion between magnet and the coil is called electromagnetic induction, and when magnet is moved toward the coil, current is anti-clockwise, and current is anti-clockwise from this diagram, this end A becomes north pole. And when current is clockwise, when magnet is taken away from the coil, current is clockwise at end A, so it becomes south pole. Because any coil or solenoid like carry current behaves like a magnet. So this is the definition of E.M.Induction. So what is the cause of E.M.Induction? What happens when there is relative motion between the magnet and the coil? What changes? So when magnet is moved into the coil, and we know that bar magnet has magnetic lines of force from north to south, inside south to north, they form closed loops. It means when magnet is moved towards the coil, the magnet is moved into the coil, magnetic lines of force threading the coil will increase. They will change. In other words, magnetic flux linked with the coil change increases. And when it is taken away, magnetic lines of force threading the coil will decrease. So magnetic flux decreases. Because magnetic lines of force is nothing but magnetic flux. It means when we move bar magnet towards or away from the coil, magnetic lines of force threading the coil change. As a result, magnetic flux linked with the coil or the circuit changes. And due to this change in magnetic flux, induced EMF is produced. So the cause of magnetic flux, cause of electromagnetic induction is nothing but change in magnetic flux. So magnetic flux changes, whenever magnetic flux changes, induced EMF is produced. And from this result of this experiment, Faraday's experiment, Faraday's made Faraday's laws of electromagnetic induction. So first law states that whenever magnetic flux linked with the coil changes, induced EMF is produced. This is first law. Second law, the induced EMF produced lasts till the change in flux is going on or continues. When change in flux stops changing, then there will be no current, no induced EMF. So induced EMF lasts till the change in flux continues. Change in flux is going on. This is second law. So you can write one or two together also. Third, I have said when magnet is moved rapidly, induced EMF produced is more. When it is moved slowly, induced EMF produces less. It means induced EMF produced, the magnitude of induced EMF so produced is directly proportional to rate of change of magnetic flux, or E is proportional to phi 2 minus phi 1 upon T, or E is equal to minus phi 2 minus phi 1 upon T, or E is equal to minus d phi by dt. So the magnitude of induced EMF so produced due to change in magnetic flux is directly proportional to rate of change of magnetic flux. And the negative sign indicates that it is of opposing nature. This is Faraday's third law of E.M.Induction. Then current E by R, according to induced EMF, I is equal to E by R or minus 1 by R d phi by dt. So we can also find current so produced. Then the direction of induced EMF, I said it is opposing nature, is given by Lenz'S law. So Lenz'S law gives the direction of induced EMF, and this law is in accordance with the law of conservation of energy, I will prove. So it means state Lenz'S law. If you ask state Lenz'S law, so it states that the direction of induced EMF is such that it opposes the cause that produces it. It opposes the change that produces it. ਜਿਹੜੀ ਚੀਜ਼ ਇਹਨੂੰ ਪੈਦਾ ਕਰਦੀ ਹੈ ਪ੍ਰੋਡਿਊਸ ਹੋਣ ਤੋਂ ਬਾਅਦ ਉਸੇ ਨੂੰ ਅਪੋਜ਼ ਕਰਦੀ ਹੈ ਇੰਡਿਊਸਡ ਈਐਮਐਫ how it is in accordance with law of conservation of energy? No, when magnet is moved toward the coil, I said magnetic lines of force threading the coil increase, and A becomes north pole. Current is anti-clockwise. Deflection is towards left. It means when we introduce the magnet with north pole downward into the coil and A becomes north pole, so it means there is force of repulsion between north of the magnet and north of the coil. It is work has to be done in order to move the magnet towards the coil against force of repulsion. Similarly, when magnet is taken away and A becomes south pole, then north-south attracts. So there is force of attraction between north of the magnet and south of the coil. So work has to be done. If we have to move it away, work has to be done against force of attraction between the two opposite poles. So it means during inward or outward motion, work has to be done against force of repulsion during downward motion and against force of attraction during outward motion. And this work done is being converted into energy. Energy कित्थों आ रही है? There is no battery in the circuit. Galvanometer is giving deflection. So it means this change is nothing but conversion of one form of energy into another form. So amount of work done, work is done in order to overcome force of repulsion during downward motion and force of attraction during outward motion, and that work done is being converted into energy, and that is nothing but electrical energy. So one form of energy is being converted into energy. So it means Lenz's law is nothing but it is in accordance with law of conservation of energy. So this is all about magnetic flux, Faraday's laws of E.M.Induction and Lenz's law, and it's in accordance with the law of conservation of energy. It means Lenz's law obeys the law of conservation of energy. So till next video, stay tuned. All the best. Be happy. Good luck.